Impact of human activity. Our influence on the atmosphere. You learned how gases like methane, water, and carbon dioxide help keep the Earth warm enough for life. The greenhouse gases absorb long wavelength radiation and re radiate it back to the Earth's surface. After measuring ice cores, sediment cores, and isotopes in rock samples, scientists have found that the concentrations of methane and carbon dioxide have fluctuated over time. As the concentrations of these gases have risen, the global climate has warmed. As the concentrations of these gases have fallen, the global climate has cooled. These concentration fluctuations and climatic changes took tens of thousands to millions of years to happen. In our picture, we see the incoming solar radiation from our sun, and then we have the outgoing long wavelength radiation as it bounces off the Earth. But then we have our atmospheric gases, those greenhouse gases that bounce it back and re-radiate long wavelength radiation. Over the past 150 years, however, we have increased the greenhouse effect by changing the amount of atmospheric greenhouse gases, particularly carbon dioxide and methane. Over that time, we have increased the carbon dioxide in the atmosphere from 280 parts per million to over 400 parts per million. The increase in these gases has resulted in increased absorption of energy in the atmosphere. This has led to a rise in global temperatures, known as global warming. Since increasing the global temperature changes the long-term averages and variations in weather around the world, scientists are referring to these effects as global climate change. Global climate change causes changes in temperature, precipitation, glaciation, frequency and strength of severe weather, and acidification of oceans across the globe. Pause and go answer question number 10 on page 14 in your science notebook. Global climate change. Temperatures worldwide have shown an upward trend over the past 200 years, with the 10 warmest years on record having occurred within the last 2 decades. This trend is shown in the graph. As this trend continues, polar ice caps and mountain glaciers melt at increasing rates. This will lead to a rise in sea level and the flooding of coastal cities. Other consequences include the spread of deserts into fertile regions, an increase in sea surface temperature, ocean acidification, and an increase in the frequency and severity of storms and droughts. On our graph, we see our global temperature trends from 4 different agencies recording temperatures between 1880 and about 2014-15. And we see our change in temperature kind of started to rise here in the 40s, stabled off for a bit, but then since about 1980 has dramatically risen. Okay, we've got a big jump here. That's a very short amount of time when we're talking about climate. Burning fossil fuels. One of the main sources of atmospheric carbon dioxide generated by humans comes from burning fossil fuels, including coal, oil, and natural gas. 98% of carbon dioxide emissions in the United States comes from burning fossil fuels to run automobiles, heat homes and businesses, and power factories. Almost any process that involves the burning of fossil fuels results in the release of carbon dioxide. Burning fossil fuels also releases other greenhouse gases, such as methane and nitrous oxide, into the atmosphere. Pause and go answer question number 11 on page 14 in your science notebook. Deforestation. Deforestation, the mass removal of trees, also plays a role in increasing levels of atmospheric carbon dioxide. During photosynthesis, vegetation removes carbon dioxide from the atmosphere. When trees, such as the ones shown in the photo, are cut down, photosynthesis is reduced, and more carbon dioxide remains in the atmosphere. Scientists have found that deforestation intensifies global warming trends and other effects of climate change. Pause and go answer question number 12 on page 14 in your science notebook.